Hello everyone. In today's Student's Quest, we have to solve this definite integral problem, and it is asked to find out the integral of 0 to pi. The bounds are there, and the numerator of this integrand is x squared cos square x minus x sin x minus cos x minus 1. The denominator is 1 plus x sin x the whole square. So usual temptation is to find out the integration or try to find out the integration by using properties of definite integration. But believe me, it's a very long or maybe impossible route for that. So what we do better, we simply find the indefinite integration, dropping the bounds, and then whatever the integrand will come, we will find the integral value on that. So for that, let's observe the numerator first. So numerator, what we have is x squared cos square x minus x sin x and minus cos x minus 1. The denominator is a very interesting one. You notice that the denominator what we have is a factor x sin x, and this factor is going to help us. This is the complete denominator, and I have 1 plus x sin x. So observe this thing. If you try to differentiate the 1 plus x sin x only, what I'm getting is x cos x and plus sin x. And this x cos x is the hint how to proceed. So x cos x, you can see it is here, but it needs only one factor. So what I'm going to do is I try to create the denominator, this factor derivative. The factor of this denominator factor is 1 plus x sin x. I want to create the derivative of this on the top. And from there, we manipulate the numerator and see whatever we have to add and subtract. And then we will try what we have. So see here, I'm dropping this idea of the integration with limit. So what I'm going to do, I'm writing this x squared cos x as x cos x, and then multiplying this with x cos x plus sin x. In that way, what I did, I just created the derivative of, you can see here, the derivative of 1 plus x sin x, it is over here. But in the process, what I did, I just added extra term. What that extra term is, x cos x sin x. I'm subtracting x cos x sin x to compensate it. And whatever extra we had previously, I'm going to write minus x sin x minus cos x minus 1. And the denominator as it is, I have 1 plus x sin x the whole square and with dx. Now I'm going to separate this entire thing into two integrals. First is, if you notice, I can take this thing together. So of course one is going to be, this is going to be derivative of this, so we can manage this thing. So here I have x cos x, and this is x cos x plus sin x with the same denominator as 1 plus x sin x the whole square. And in this four terms what we had, from each of them I have the minus sign to take it out. So I've taken the minus out, and by the way dx is here, don't forget, and there I have x cos x sin x plus x sin x plus cos x plus 1, and that is again 1 plus x sin x the whole square. Now notice one thing, that these four terms can be factored very easily, because from these two terms I can take x sin x common. So I will left out cos x plus 1, and here also cos x plus 1. So these four terms will turn into this one. I'm writing here. This will become x cos x not x cos x, x sin x plus 1 into cos x plus 1. And in denominator, what I have is 1 plus x sin x, the whole square. Of course, these two will get cancelled from here. This will get cancelled. And this is our integration number I1 I'm writing just to save the time. So this is going to be I1. Now I have this factor remains. We will see how to manage. So first of all, I'm going to integrate this I1 by using by parts. So let me write it first. That is x cos x, or let me just copy this thing from there. So now we have to integrate this I1, and what is this? We can see that this can be taken as u by use integration by parts. I'm going to do is, so and this is u here, and this completely will be v because the derivative of this quantity is given there. So what I can write is x cos x, and its derivative is there, so that can be directly written as negative of 1 by u, that is 1 plus x sin x. And minus, we are going to write the derivative of this, so it will be x into minus sin x plus cos x. And again, this going to be with a minus sign, and then 1 plus x sin x and dx. Now you see there, these two things I have with a minus, means what I'm going to do, this is minus here and this is also minus here, and both has the integration here. So I'm going to collect this thing together. How do we collect? I have this entire I now, not I, the integration whatever we have, that's the I1 is minus x cos x divided by 1 plus x sin x, and these two I'm collecting, so the minus sign is common, and then I will get here minus x sin x, and or maybe we can write here plus x sin x and minus cos x divided by 1 plus x sin x, because this minus will be multiplied to that. And this, from the yellow thing, I can get this entire thing. There's 1 plus cos x, 1 plus sin x. Sorry, 1 plus cos x and plus divide by 1 plus x sin x. Now notice if we collect them together, what I'm getting this as this cos x and cos x get cancelled, and here 1 plus x sin x and 1 plus x sin x will also get cancelled. So we are getting now directly minus x cos x divided by 1 plus x sin x, and that is going to be minus dx. And so our integration, what I'm looking for is 0 to pi minus x cos x 1 plus x sin x minus x from 0 to pi, and when we evaluate it we get the answer as 0. So that's it for today's video. See you in the next video with some other good example. Till then, stay math active.